Hey guys, we are going to be looking at complex numbers and roots. Okay, what I've put together is some vocabulary that if and when you are availed of a couple of minutes, I'd look these words up for the definition and examples because they're going to be very fruitful in your complete understanding of this material. Okay. Now before we move forward, the one thing I am going to stress is this fact, okay, that there's an imaginary number, okay, they're all over the place, but they all have this one component I, which is really the equivalent of a negative underneath the radical, okay, specifically -1 or the square root of -1 is what is equivalent to I, okay, or this imaginary number. So that's gonna be very important as we move forward with this. So long story short, if you've ever wondered, hey, can you take the square root of a negative number? No, in the real world of numbers, but yes, in the complex set of numbers. Okay, that might be too much information, but hopefully that's a good intro to get us started. Okay, so be on the lookout for anytime there's a negative. Okay, I'll give you a quick example. Let's talk about the square root of something simple, -2. You can easily write it as, let's see here, 2 times -1, which equals square root of 2 times the square root of -1, which is equal to the square root of 2i. Notice how I was able to basically factor out this negative component. Now this I is not inside the radical, so typically what is done in mathematics is they'll write it up here in the front so it doesn't get confusing, but it's been factored out. With that said, let's go and look at these problems. Okay, express this expression in terms of I. So let's get into this guy. Again, I've got 8 in here. I'm quickly gonna factor out the -1. Okay, for that product. So what that's going to allow me to do, just like I showed you guys, is kind of deal with it separately. Right? As you can see here now, we have 8. Okay, this already becomes I. This other portion here, what we can do is what we've been doing the last couple of days is simplifying. Now there's different techniques. Alright, let's take a look here. Let's actually use the calculator here as a refresher. So menu, number, factor, 84. Okay, and I got 2, 2, 3, and 7. Alright, so I got 2, 2, 3, and 7. There's that one pair, right, that we've looked at. So now I have 8 times 2. I'm going to leave the 3 and the 7 in there, and the I, I'll put it back here. Right. So now I have 16 square root of 21 I. Alright. Now keep in mind that that I can get kind of lost back there, so it's good practice to put the I up front. Just like that. Okay? Alright, let's move on to the next one. Okay, solve the equation. 2x squared plus 18 equals 8. Alright. What I'm going to do here is, alright, sorry about that. Let's go ahead and subtract 18 to both sides. 2x squared equals -18. Divide by 2. You got -9. Now that good old radical, help us cancel that square. It's going to leave us x equals plus or minus the square root of -9. Okay. Now again, there's a lot happening here, but you guys got it. Just take it one step at a time. One thing you can do is kind of separate that. So you've got the square root of 9, right, the positive version, and then you have the negative version. I'll keep the negative inside, must be in there. So once it's in this form, then you can go and factor out that -1. Now at some point you might be able to skip a step, but for now let's play it safe. So I'm going to factor out the -1 times 9 there, the -1 times 9 there, and x equals, right, I'm going to go ahead and take out the I part. Let me do it a little slower. I don't want to lose anybody. So we've got this part times that part, comma, this part times that part, and let's not forget this negative up front. Alright? So then I have I, right? There's the I. This is 3, comma, this is I, but notice the negative, so a negative I, and then 3. Alright? Now, just FYI, you do want to put that I up in front of the radical at the end, but in back of the whole number, or I guess we can say the coefficient. So we'll present it as 3i, comma, negative 3i. Alright, there's a solution there. Alright, next up, let's look at this kind of problem. Now this one looks very intense, so knowing what to do is going to be even more critical than ever. Alright, because there's a quick fix to this. Okay. Now, as you'll explore some of these types of numbers in the complex set of numbers, you'll notice that this form is very common. Alright, but in terms of finding the value of x and y that makes this equation true, let me just show you what to do here so that tomorrow you can perform the functions and the actual understanding. Maybe we can elaborate through some questions, comments, things like that. Okay. Alright, so how do you get the x? Well, simple. If this expression is equivalent to this one, we can simply set them equal to each other. Negative 9x should equal this component that has a negative 54. Divide by negative 9 and we see x is 6. Okay, done and done. This other component, right, which has the 8i, right, should be equal to this other component over here, which is what? The 16y. Okay. Notice that this I is consistent, so we'll let it remain intact. So, and I put it up here. Okay, I do apologize. All right, so it's 8 equals 16y. Let's go and do the quick math on that. And we get that y is equal to half. All right. So, bottom line, you can perform the process of how to get x and y. Now let me tell you a little bit about the y here, okay? Because when you describe these types of numbers, they have this form a plus bi, right? And this is the real component, and this is the imaginary component. So that's essentially what we've done here, is allow ourselves to describe these two numbers which are stated as equivalent, do some math to get what values allow us to have equality, but then the number up front here, okay, would be the real component. This part back here would be imaginary. Alright, let's move on to this next one. It says find the zeros of the function. These hopefully have become a lot easier and funner for you guys, so let me get into this one. Okay, now yesterday we talked about completing the square. You'll notice that this 18 doesn't really help us complete the square, so the quick fix is going to be the following. Okay, right? Once the 0, so you set it equal to 0. Since he's not really helping us, I'm actually going to get rid of him through subtraction. Okay, so minus 18, minus 18. So he no longer exists. So now I'm looking at this situation. Now what this is going to allow me to do is complete the square like we did yesterday. Okay, plus something equals negative 18. Well, by now, in yesterday's practice, you know that it's b over 2, that squared. So it's 6 over 2, which is 3 squared, which is 9. Alright? So I'm going to add 9 to both sides. What that does, it helps me factor it out, and I'm doing it a lot faster than yesterday. So if you need to practice, look at your notes, do some of those practice homework exercises. But this is where it leads me, right? I do this. This is negative 9. Right? At this stage is where we can take the square root, and this should look very familiar. You now have x plus 3 equals plus or minus square root of negative 9. Alright, so now you've got this bad boy to deal with. What I suggest, especially as you get better at this, is essentially now you have plus or minus I, or what is it? Right, you guys know the square root of 9 is 3, so take advantage of that. You know that the square root of a negative 1 inside is I, so we can break it up as plus or minus 3i. So then all you have to do now is subtract 3, and you have x equals plus or minus 3i minus 3, which is equivalent to saying 3i minus 3 and negative 3i minus 3. Okay. And what do we have here? Find the complex conjugate. Here's the last one. Okay, not very difficult at all. All you have to do is understand, pay attention, that if you're given some number a plus bi, then the complex conjugate is simply a minus bi. Okay? So we're looking at 3i plus 4. So how do you turn that into its complex conjugate? Okay, you want to observe that 3i plus 4 doesn't really match here perfectly. So what I'm going to do is I'm going to rewrite it and put the 4 up front and put the 3i in the back. So I have a perfect match, right? A is 4 and B is 3. So now I can simply apply this, and 4 is A. I need a minus there and a 3i. Guys, it's been 12 minutes. Thank you so much for your time. Take good notes and ask a lot of questions. Thank you for your time.